So we discussed that today experiment is measurement of gear tooth vernier caliper. Aim of this experiment to measure gear parameter by gear tooth vernier caliper. Apparatus required. So we have two different gears. One is aluminum and another one is mild steel. Big one is for aluminum and small one is for mild steel. Then gear tooth vernier caliper. These are the apparatus required to measure the gear tooth dimensions. Then procedures. So first, the number of teeth on gear blank was conducted and diameter was measured. Calculated the module of pitch circle diameter of gear. By the above formula, the depth and thickness of the given gear was calculated. Then calculate the tooth thickness by normal measuring. Then compare the theoretical value with the practical value, and error is noted in the difference by the tabulation. So this process is repeated for different teeths and values are tabulated. So formulas we are using for this gear tooth vernier caliper, we have to find it for width and depth and module and percentage of error for the required formula. So this is a gear tooth vernier caliper. We can use to two different parameters to this gear. Okay, so in this gear tooth vernier caliper, they have two positions. One is horizontal position and another one is vertical position. So in this horizontal positions, we had 0 to 100 mm for the main scale reading and vernier scale reading 0 to 0. So each one is have 5 units. So 1 by 49 for the one vernier scale. So the least count is 1 divided by 49 equal to 0.02 is the 0.02 is the vernier caliper gear tooth vernier caliper least count. Okay, so similarly we can use to calculate for the depth of the gear tooth vernier caliper. So the reading is 0 to 80 mm. So that vernier scale reading similarly for the horizontal positions 0 to 0. So we have 49 divisions. Okay, so easily to calculate by the gear tooth vernier caliper to using by the different gears. We have using this tabulation to calculate the outside diameter of the gear. This is the first table, and second table we can use to be here for this calculations of different specimens, and gear 1 for the smallest one and gear 2 for the biggest one. Okay, so now we have to calculate it for the number of teeth first and outside diameter, and similarly we have to calculate the other things. So now we can find it for the outside diameter of gear. So we can use to calculate the outside diameter for the vernier caliper to measure the experiment to measure the gear. So we can outside diameter is nearly located is 76. So which is noted is the 76 is the main scale reading. Main scale reading, and the 5 divisions are to be noted from the vernier scale reading. Hence has to noted or have attained by the vernier scale reading. Calculated 76 plus 5 into the least count 0.02. So we can get from that gear 1 is 76.1. Okay, so this is the outside diameter of the gear. So we can similarly we can take as 2, 3, 4, 5 dimensions we can get as the average value, similarly for gear 1 and gear 2. So now we can calculate for this big gear to the gear tooth parameters like chordal depth and thickness of the gear, right? So first we have to calculate chordal thickness. So in this thickness we have to calculate it here in this vertical section. So here we can calculate it is the gear is 3 mm for the vernier main scale reading, 3 mm here, 3 mm. Here is the vernier scale reading, and we can calculate it as similarly for the main scale reading is 3 mm, and calculated as the main scale reading is connected to the first line, so that is reading is 1. Okay, so we can calculate it here. The chordal depth 3 into 0.1 is the vernier scale reading. So 0.02 is the least count, so we can attain by the big gear of the chordal thickness is 3.02 mm. Okay, so similarly we can calculate it for the thickness of the chordal thickness of the gear. So in this horizontal position we can calculate it. So here also we can attain by the 3 mm. So from the three different area of the gears teeth, so all the dimensions are in 3 mm from the chordal thickness. So we are calculated by the chordal thickness is 3 mm for the teeth 1, and 3 mm for the teeth 2, and 3 mm for the teeth 3. So for the average is 3 mm for the chordal thickness. Okay, so remaining things we have to calculate it by the standard chordal thickness, so which is calculated by the first one is height. So this is the formula for the calculating for the height. So nm by 2, 1 plus 2 by n, and cos 90 by n. So already we know this total number of teeth is that total teeth of this gear is 45, and the module already we have to calculate it. So the module value is 1.49. so the module formula is m equal to dc by n plus 2. Okay, so the dc, it is a maximum average of the outside diameter, which is calculated by the vernier caliper. So n is the total number of teeth plus 2. Okay, so we can get as the module value is 1.49. so that's why we can put it here 1.49 by 2. Okay, so then another one is 1 plus 2 by n. So n already you know that is the 45 is the number of teeth. Okay, then cos minus cos 90 by n. So minus cos 90 divided by 45. So we can get as the value is height equal to 1.525 mm. Okay, so this is the height value of the gear 2, right? So again we can calculate from the theoretical value for the chordal thickness. So this is the formula for the chordal thickness finding by the theoretical value. So mn sin 90 by n. So mn already we know 1.4. So mn it is a module, so that is 1.49. so n it is a number of teeth, so it is a 45. so sin into 90 divided by 45. so we can calculate it by the theoretical to the chordal thickness value is 2.34. Okay, so this is already we discussed by the chordal depth. So 3 into 0.01 into 0.02. so d value is 3.02. Okay, so finally we can attain by the standard chordal thickness value. So the formula is ws equal to pi into m by 2. Okay, so by already it is a constant, and 1.49 is the module value by 2. Okay, so from the standard chordal thickness which is ws in the unit of mm, we can get as 4.68 mm. So final we can get from the big gear of the aluminum piece of the gear. So we can get as maximum ws value is 4.68, and 3 minus 3 divided by 4.60. so the percentage of error is 0.35%. Okay, so finally we can get the result. We can get the result. We can get the result is error percentage in gear 1 and error percentage in gear 2. So thus the chordal thickness and addendum of gear is measured using gear tooth vernier caliper.